Right. Okay, we've got Simon Pattison here from Kingspan. We're going to ask him a few questions about MCS and installing and heat pumps and maintaining them. So Simon's the training manager at Kingspan, so he's got a lot of knowledge. So we're going to ask you a few questions. So first of all, let's talk about preparation and installation, Simon. So when you're installing a heat pump, you've got to take make a heat loss calculation. So and you have to do that under MCS. So it should be carried out pre-installation. But why is this necessary?
Yeah, the reason why we'd have to do a heat loss calculation is because the property is insulation really. If you're generating heat, and because heat pumps generate at a very low temperature, if we're going to generate heat, the last thing we want to do is lose heat. So what we do is we actually do a room by room calculation, find out what the U values are, and then we look at how we can reduce the U values. Once we've done that, then we can size the heat pump accordingly. There's no point in oversizing a heat pump because it could be defrosting more, or if you undersize it, then it could be overworking. So this is the reason why MCS do require a heat pump calculation. A heat loss calculation.
Okay, excellent. So what type of buildings are best suited to heat pumps then?
Well, any with good insulation levels. Obviously a wooden hut wouldn't do because obviously the insulation would be too good. So any property that has got the good insulation, so cavity wall insulation, whether you've got the external wall or whether it's interior. So it's always got to be a well insulated property basically is the answer to that one.
Okay, excellent. And what about the outdoor unit? Is that got to be positioned somewhere specifically?
Well, every manufacturer will have their own rules. Usually it's probably a metre around. What we've got to look at is the airflow. So if we have the heat pump too close to a wall, what we end up doing then is having the recirculation of air. So that's one reason. The other reason is because of noise. We're not going to put it underneath somebody's window because we have got a fan, so it does actually generate noise, usually about 42 decibels. So anywhere where people are sleeping, we wouldn't want to put it there. So really it's away from walls, away from living quarters and things like that.
Okay, brilliant. And underfloor heating seems best suited to heat pumps. So let's talk about that and about oversizing of radiators.
Yeah, the underfloor heating is probably one of the best ones because it's designed to run at a low flow temperature. Heat pumps are designed to run at about 35 degrees for the heating circuit. So if we can, with the emitter being the underfloor, it's actually all over the floor, it's all around the floor, so the heat will then rise at a lower temperature. Now if we're going to do it on radiators, we would then have to oversize radiators because on the normal heating system the radiators will emit at about 70 degrees, so because we're halving that temperature, then what we'd need to do is then oversize the radiator to meet that demand if we was going to put radiators on. But underfloor probably is the best solution.
Okay, brilliant. Does low temperature heating require different plumbing and pipe sizing then?
It depends. I mean, it's usually the same sort of heating circuit as a boiler, but because you are running at a lower temperature, then you've got to think about the flow rates. Now, obviously, sometimes there's no point putting microbore in like a lot of new builds are doing now because it's only 10 mil. So with a heat pump, you're looking at probably the flow rate is about 8 litres a minute. So, of course, you've got to do your calculations and find that you are going to get that 8 litres a minute around that emitter circuit.
Okay, brilliant. And also, obviously, we've got Green Deal and RHI coming up. Do I need a Green Deal assessment as well for a heat pump?
For RHI, to gain access to the RHI, then yes, you will need a Green Deal assessment. Obviously, at the moment, the RHI isn't out there, so if they were going to do that, then no. But I would always say yes.
And are there any other qualifications or certifications I need for this?
Well, obviously, I mean, according to for MCS, you do need to have those qualifications. Then MVQ level 3 plumbing is required because you're doing with the heating circuits. Because we do monoblock systems, you don't need the F-gas. But obviously, it's designing systems, designing the heating systems. Then obviously if you're putting an unvented cylinder in, then you need the G3, water regulation. So yes, there is more qualifications that you do need, yes.
Okay, brilliant. And let's talk about some of the components then. Where should isolation valves, filters and drain down points be positioned?
Right, the drain down points probably first and foremost should be the lower end of the system, so that obviously we can get all the fluid out if we need to. All isolation points really need to be in an accessible position. Usually if you've got a plan room, they'll put them in a plan room. If not, then somewhere accessible. So for maintenance purposes and things, filling, flushing, then obviously we need to get to them.
Okay, fantastic. Let's move on a bit now to commissioning. We've done the sort of installation and preparation, but talk to me about sort of some of the key steps and common faults. So let's start talking about pressure tests and flush and that type of stage of commissioning a new heat pump.
Yeah, well, obviously we've got to commission the pressure test the system. Now the worst thing is having debris in the system, so we need to flush all the debris out of the system. A lot of people will do this just with the normal water fill, and then what we need to do then is empty the water fill out and then put an inhibitor or glycol into the system. When commissioning them, then obviously we've got to look at the flow rates. So yeah, I mean the commissioning side of things is probably one of the most important parts of the installation.
Yeah, excellent. So on a more general point, why heat pumps are more efficient in certain ways, obviously, than gas boilers. But with RHI and everything coming along, why aren't more people installing heat pumps at this stage?
Well, at the moment, I mean, RHI will be a big push for the heat pumps, but at the moment, a lot of people are still in the perspective of combi boilers being 98% efficient. Now, the reason is because you've got instantaneous hot water. Now, a lot of people have got gas on site, so they'd rather go for the cheaper option of the gas boiler because the cheaper, yes, you do get the instantaneous hot water. With heat pumps, they actually rely on electricity. Now, coming to efficiencies, then you've got a gas boiler that is probably 94% efficient, 98% efficient. But when it comes to heat pumps, it can be 300% efficient. And that basically means you can put 1 kilowatt of electrical energy in to generate 3 kilowatts of heating energy. So we've actually got that more efficiency within the heat pump itself.
Okay, that's excellent. Let's talk about now the handover stage, because obviously this is an important phase of commissioning and handing over. So talk to me about setting the program with the homeowner and why that can be helpful.
Yeah, I mean, when you actually commission a system, then the ideal thing is to have the customer there for the handover, because they will want to know how to set the parameters. If they do need, for example, in summer they may not want the heating on, so they'll then need to go into the program and then turn it off or put into a holiday mode or whichever mode they want to do. So to explain to a customer how the system works, how the system is actually set up, then what they need to do is know how to do that, because sometimes they may have a little fault error on there. It may not be a fault of their own, but instead of having to come out and reset it, they may be able to do that themselves just by pressing a button.
Yeah.
But on handover, then yes, it's a requirement to have the customer there, because obviously it needs notified to building control for the inverter cylinders as well.
Yeah. Okay. Excellent. And what about annual servicing? Do they need an annual service on heat pumps?
I would say yes. I mean, manufacturers will state that if they're giving a warranty out, then they will need to have an annual service. I mean, the servicing with the heat pump is very minimal. There is, it's basically just clearing around the fan, the emitters, the evaporators, just to make sure that there's no leaves, and basically just to make sure the system's running okay. It's more of a visual check than it is anything else.
Okay, great. So we're on the standard heat pumps, hands-on heat pump session today. But there are a number of different units here. But obviously with Kingspan, it's different. Your unit here is different from those other manufacturers on the stand here. So why do the fan and evaporator sizes vary so much in these heat pumps?
Basically, it's the bigger the fan, the bigger the evaporator, and the larger the heat pump. So it's not a matter of that one manufacturer's got a bigger one, because not always bigger is better. What they do is you'll find that the larger the fan and the larger the heat pump size, we actually do a twin fan one, which is up to a 12 to 15 kilowatts. So again, it varies just because the size of the unit is basically the size of the heat pump.
Yeah. Okay, great. And so these are yours is a monoblock system here behind you. So what are split systems or hybrid systems?
A split system is basically where you'll have a unit outside and then you'll have a unit inside. What then happens is you'll then commission it with the gas, so with the refrigerant. So basically you'll run the refrigerant from outside the thermal envelope into the envelope. We do a monoblock because at the end of the day it's hermetically sealed, so we don't have to have the F-gas certification. to install our product. A hybrid system is basically where you'll have a boiler, which is basically called a bivalent system, which will have a backup boiler. So, for example, a gas and oil, LPG, you could have that incorporated into the system. But because obviously for RHI the heat pump has to do 100% of the demand, so it has to be sized for 100% of the demand. Before you could put a bivalent, probably do the heat pump to run 70% and then 30% of the backup boiler from there.
Okay, excellent. And some people are worried about noise from the heat pumps. So is that an issue with heat pumps?
No, not at all. I mean, they're not as loud as most things. They're all about the same. I mean, between 42 to 52 decibels. So again, it's not like a helicopter taking off. It's just like a normal air conditioning unit, really.
Yeah. Okay. Right. Well, that's the end session. But hopefully, there's been useful questions and answers from Simon Pattison from Kingspan, talking about sort of some of the issues of installation of heat pumps and making the transition from gas installation. Thanks a lot, Simon. Cheers.
Thank you.